All right, certified brainiacs, welcome back to Ancient Absurdity, where history's brightest minds make humanity's biggest oopsies. Hit subscribe before you accidentally invent mustard gas in your kitchen. You think genius means wisdom? Think again. Across the centuries, brilliant men and women have turned curiosity into chaos, discovery into disaster, and occasionally gold into urine vapor. So buckle up, time traveler. We're going on a 1-hour tour of human brilliance at its dumbest. Block 1. The alchemists, turning lead and logic into smoke. Before science had lab coats, it had wizards with poor ventilation. These were the dreamers who tried to turn pee into gold, mercury into medicine, and curiosity into chemical warfare. All before breakfast. Paracelsus, 1493–1541, self-poisoned by his own medicine, proving that clinical trials are not optional. You wake up in a 16th century workshop that smells like hot vinegar, wet metal, and the moral panic of a university faculty meeting. Copper pots hiss. A crucible glows. A physician in a battered cloak is stirring something that looks illegal in 12 countries. He turns, eyes bright. "I am Theophrastus von Hohenheim," he says, "but you may call me Paracelsus." You clock the swagger. Anyone who literally renames himself beyond Celsus has the confidence of a man who seasons dinner with mercury and calls it treatment. He was born in Einsiedeln around 1493 and dies in Salzburg on 24 September 1541. But in between he bends medicine toward chemistry with pure force of ego. Paracelsus hates the syllabus. He calls Galen outdated, Avicenna overrated, and lectures in German so the apprentices and the nosy blacksmith can follow along. When Basil gives him a chair in 1527, he repays academia by lighting the establishment on fire, almost literally, by reportedly burning canonical medical texts in public. It is the Renaissance version of rage-quitting a listserv. The stunt is performative, but the point is clear. Stop reciting, start observing. He insists that wounds should drain, and that nature heals if you stop stuffing gunk into people. It plays like a TED talk with more smoke. Now to his superpower, toxicology. Paracelsus coins the rule that still governs your shampoo, your painkillers, and your tap water. All things are poison, and nothing is without poison. Only the dose makes a thing not a poison. In Latin, shorthand, sola dosis facit venenum. He writes it to defend using scary-sounding minerals, mercury, antimony, copper salts, as medicines. In tiny doses they heal. In big doses they ruin your weak and your kidneys. It is elegant, brutal logic, and it births a field. Modern researchers still cite him when teaching dose response. You tweet hot takes. He invents risk assessment. Here's the punchline you can smell from 3 rooms away. He lives his maxim on hard mode. Paracelsus doses. Paracelsus. He tinkers with opium preparations that later get called laudanum, an opiate tincture he is often credited with popularizing, and he flirts constantly with mercurial therapies for diseases like syphilis. The lab routine is half pharmacy, half demolition derby. Inhale fumes, taste a precipitate, write notes before your handwriting melts. He treats pain. He also marinates his lungs. You can argue about the precise recipes, but there's no debate that he drives chemical remedies into mainstream practice by testing them on the nearest mammal, himself. Because this is the Renaissance, the workplace safety officer is a goat, and the ventilation plan is prey. Mercury vapor does what mercury vapor does. Chronic exposure brings tremor, mood swings, mouth ulcers, and the kind of irritable genius that gets you banned from dinner parties. Historians still dispute his ultimate cause of death: assault, fall, illness, or toxicity. But even conservative biographies agree the end is mysterious, and the exposure was real. The irony lands with surgical precision. The father of toxicology may have been slowly undone by the same metals he preached about so loudly. The dose makes the poison. The dose also makes the legend. Picture the scene. You're his assistant, holding tongs that weigh as much as guilt. He's demonstrating the tria prima, sulfur, mercury, and salt, as the three principles of matter. He burns a piece of wood. Flame is sulfur, smoke is mercury, ash is salt. It's a beautiful wrong idea that still drags chemistry forward. He is wrong in the right direction, like a GPS that insists the Alps are a roundabout, but still gets you to Italy. And as he rants about invisible virtues, he injects the crucial modern habit: measure, compare, dose. That's why, centuries later, public health standards are basically Paracelsus, with a spreadsheet. He is also a chaos gremlin. He picks fights with apothecaries, trashes worthless pills, and tells physicians to learn from barbers and midwives. Imagine a medical influencer who torches textbooks and then goes on house calls. He cures enough people to become rich, loses enough friends to keep moving, and leaves behind a paper trail that is part science, part prophecy, part performance art. You don't have to like him. You do have to admit the man is gasoline on the dry timber of medieval medicine. Final beat. You watch him seal a vial, cough, and grin. A doctor must be a traveler, he says. Knowledge is experience. Then he downs his own concoction to prove a point no ethics board would permit. Somewhere, the 21st century nods grimly. Clinical trials are not optional. Paracelsus found the law of poison by standing inside the cloud. The rest of us have IRBs, so we don't have to. Hennig Brand, 1669, discovered phosphorus while boiling 5,000 liters of urine. Nearly set Hamburg on fire. You wake up in 1669 Hamburg, and the first thing you smell is, well, you don't know yet, but you'll wish you didn't. The room looks like a medieval brewery that lost an argument with a sewer. Barrels everywhere. Steam. The air has the distinct bouquet of science before plumbing. In the center stands Hennig Brand, a former soldier turned alchemist, proudly stirring a pot of human pee, like it's soup for the gods. Brand's dream is gold. Every alchemist's dream is gold. Unfortunately, he's broke. And as he's collecting barrels of urine from every tavern and barracks in town, his neighbors are collecting complaints. He believes, quite sincerely, that the essence of life, the secret ingredient that turns base metals into gold, is hiding in the body's waste. So he boils, distills, and condenses until his entire laboratory smells like the worst part of a public festival. After weeks of brewing misery, something strange happens. Late one night, the mixture dries down into a waxy residue that begins to glow in the dark. Not just a little shimmer. Actual ghost light, pulsing pale green through the gloom. Brand calls it cold fire. He has just discovered phosphorus, the first new element found since ancient times. It's 1669, and the man has accidentally invented both chemistry and the world's most cursed nightlight. At first, it's magic. Brand keeps the substance secret, convinced he's one more boil away from transmuting it into gold. He seals it in bottles, shows it off to noble patrons, and even eats a little of it to test its power. That goes about how you'd expect. The glow fades, the smell lingers, and he nearly burns down his workshop when the substance spontaneously ignites in contact with air. Congratulations! You've just invented self-lighting disaster. When the neighbors finally force him to stop cooking excrement for science, Brand sells his formula to another chemist, Johann Kraft, who in turn sells it to England for a hefty sum. Within a few decades, phosphorus becomes the foundation of matches, fertilizers, and a disturbing number of military applications. The discovery that began in a room full of rotting urine eventually fuels both the Enlightenment and several wars. Modern chemists still use his process as a warning. Never mix ambition with gallons of body fluids and open flame. Hennig Brand didn't find gold, but he did find an element that literally burns in air, smells like garlic, and taught humanity that discovery often begins with obsession, and sometimes ends with a fire hazard. You step out of the lab gasping for air, the night sky above glowing faintly, eerily, just like the jars inside. Somewhere behind you, Brand is already muttering that he's so close to gold. You decide it's time to leave Hamburg before it lights itself. Isaac Newton's alchemy phase, 1670s, spent years chasing immortality through mercury, gave himself chronic metal poisoning. You wake up in Cambridge, late 1670s. The door is locked, the curtains drawn, and the man inside hasn't seen daylight or another human for weeks. Ink, stains, melted glass, and chemical fumes fill the room like a genius's version of a crime scene. The man hunched over a crucible is Isaac Newton, the future discoverer of gravity, optics, and calculus. But right now, he's in his mad wizard era. Forget the image of calm, powdered wig rationality. This Newton is cooking mercury, antimony, and lead over open flame, chasing the secret of the philosopher's stone. He writes tens of thousands of words on alchemy, more than on physics, and his notebooks read like a mix of recipe, riddle, and mild psychosis. Green lion devours the sun, one note says. That's not poetry. It's a chemical experiment involving acids and metals that could kill you twice before lunch. The legend goes that Newton believed the physical world hid divine codes. Mathematics, light, and metal were all part of the same cosmic language. To him, turning lead into gold wasn't about greed. It was about decoding God's handwriting. Unfortunately, the lab safety standards of the 17th century were roughly, don't die too loudly. Newton handled mercury daily, heating it, inhaling it, sometimes even tasting it, to observe its qualities. Spoiler: its main quality was neurological damage. In 1979, scientists at the Royal Mint analyzed a strand of Newton's preserved hair. The mercury levels were off the charts, almost 40 times higher than normal. Symptoms of chronic mercury poisoning match Newton's later behavior: mood swings, paranoia, insomnia, violent temper, and an obsessive tendency to start feuds with everyone from rival astronomers to imaginary heretics. You could call it genius. You could also call it prolonged exposure to vaporized death metal. During these years, Newton wasn't writing Principia Mathematica. He was chasing immortality. He genuinely believed that alchemy could unlock divine truth and eternal life. His private notebooks describe purification rituals and encoded recipes for spiritual metals. He was less father of modern science and more guy on YouTube who swears he can ascend using copper powder. By day, he was a mathematician. By night, a secret alchemist scribbling symbols that even he later couldn't decipher. When his colleagues complained about strange smells seeping from his rooms, Newton told them it was for research. That research included mercury sulfide, arsenic, and antimony, an unholy trinity of toxins that made him simultaneously brilliant and slightly radioactive. Eventually, he left Cambridge for London, where he became master of the mint. Ironically, the man who once tried to make gold from base metals ended up running the British gold supply legally. He standardized coinage, caught counterfeiters, and probably wondered why everyone else still had eyebrows. He lived to 84, which is impressive considering his bloodstream was basically a chemistry set. So next time someone calls you a genius, remember, Isaac Newton discovered gravity, invented calculus, and may have slowly dissolved his own sanity in mercury vapor. The laws of motion were flawless. The lab safety wasn't. Block 2. The enlightened experimenters. Science with side effects. The Enlightenment gave us reason, progress, and a shocking lack of common sense. These pioneers lit the fuse of modern chemistry by personally inhaling, igniting, or exploding every new discovery. Joseph Priestley, 1774, discovered oxygen, then filled his house with explosive gases. Later chased out of England for political chemistry. You wake up in a cluttered 18th century study that smells like burnt air and half-baked revolution. Glass jars line every surface. Copper wires snake across the floor. A kettle hisses in the corner, but it's not tea, it's hydrogen. In the middle of it all stands Joseph Priestley, clergyman, chemist, philosopher, and the human embodiment of what if curiosity had no brakes? It's 1774, and Priestley is about to make history. He takes a bit of red powder, mercuric oxide, and heats it with a magnifying glass until it glows. A candle placed in the jar flares bright instead of dying out. This air, he writes, is 5 or 6 times better than common air. He has just isolated oxygen. Unfortunately, he doesn't realize it. He calls it dephlogisticated air, believing in the outdated phlogiston theory that claimed fire released a mysterious element. The man literally discovered the foundation of modern chemistry while using a fake map of reality. Priestley's house becomes a gas factory. He collects hydrogen, carbon dioxide, ammonia, sulfur dioxide, anything that bubbles. He writes calmly about breathing them, because self-testing is still the default setting for Enlightenment science. At one point he describes inhaling nitrous oxide and nearly passing out. His notebooks sound like a rave flyer written by an undertaker. A most pleasurable sensation, followed by a loss of all faculties. He's inventing chemistry, but also the first lab accident report. Explosions become a household hazard. Neighbors complain that his garden smells like brimstone and singed wigs. His wife, Mary, quietly moves valuables away from the laboratory wall. The man is a one-person department of energy, except he has no department, and even less caution. When a friend suggests ventilation, Priestley replies that true understanding requires proximity. Translation: he's sniffing science. But discovery isn't his only problem. Priestley is also a radical thinker. He supports the American Revolution and later the French one. He publishes pamphlets defending democracy and religious tolerance while his country slides toward panic. In 1791, a mob in Birmingham, angered by his sympathy for France, torches his house, laboratory, and library. They burn down the birthplace of oxygen for being too politically reactive. Priestley barely escapes with his family and a handful of notebooks. Exiled by fury and smoke, he flees to America in 1794, settling in Pennsylvania. There, he continues experimenting, preaching, and possibly alarming the neighbors again. He never renounces his ideas. He also never stops believing in phlogiston, the imaginary stuff that explained fire. The man who gave us oxygen died still thinking he hadn't found it. He passes away in 1804, surrounded by bottles of gases and the quiet hum of an intellect that refused to rest. Today, chemists honor him as a pioneer who isolated dozens of compounds, mapped unseen worlds, and accidentally turned his living room into a potential bomb range. You step out of his smoky study into the cold air of Birmingham, coughing, eyes watering. Behind you, Priestley is already lighting another experiment. For truth, he says, one must risk a little fire. In his case, quite literally. Humphrey Davy, 1807, invented laughing gas and tested everything on himself, eventually burned his lungs for science. You wake up in a Georgian laboratory that sounds like a mix between a pub and a fireworks display. Glassware clinks, gas hisses, and somewhere in the corner, someone is giggling uncontrollably. That someone is Sir Humphrey Davy, chemist, showman, and the world's first man to nearly laugh himself to death in the name of science. Born in Cornwall in 1778, Davy grows up fascinated by explosions, which is both adorable and terrifying. By his 20s, he's running experiments in the basement of the Pneumatic Institution in Bristol, studying airs for medical use. It's 1799, and doctors believe that gases might cure everything from tuberculosis to melancholy. Davy, being Davy, decides that the best test subject available is himself. He fills a bag with a new gas, nitrous oxide, and inhales deeply. The room spins. He bursts out laughing, collapses, and scribbles in his notebook. "I am more happily disposed than ever before. Congratulations, he's just discovered laughing gas." He proceeds to test it on everyone who visits, friends, poets, even the future Coleridge, until the entire British intelligentsia is high and very philosophical about it. Science has accidentally invented both anesthesia and the frat party. But Davy isn't done. He moves on to more dangerous gases, carbon monoxide, chlorine, and nitrogen dioxide. Each one gets the same treatment: inhale, observe, nearly die. His logic is impeccable. If it doesn't kill me, I've learned something. By 1801, his lungs are the most chemically diverse environment in Europe. He writes detailed notes about each effect, ranging from slight dizziness to temporary blindness to violent coughing and extreme chest pain. Occupational hazard meet enlightenment enthusiasm. In 1807, he isolates potassium and sodium by running electric currents through molten salts, discoveries that earn him fame across Europe. He also invents the Davy safety lamp, which saves countless miners from methane explosions. Ironically, the man who spent years inhaling poison becomes a hero for keeping other people alive underground. His experiments, though, exact a cost. Repeated exposure to noxious gases and acid vapors leaves his lungs scarred. Colleagues describe him wheezing through lectures while insisting he feels quite invigorated. He keeps experimenting anyway. Davy embodies the Enlightenment's greatest flaw: absolute faith that intellect can outrun mortality. By 1829, he's retired to Italy, still writing, still coughing. When he dies that same year, he leaves behind the foundations of electrochemistry, the concept of chemical bonding, and the phrase laughing gas, which, thanks to dentists and college students, will outlive him by centuries. You stand in the smoky lab as the last hiss of gas fades. Davy, eyes bright, smiles through the fog and says, "Nothing sharpens the mind like a brush with suffocation." You take one step back toward the door. Science smells funny today, and you'd rather not find out why. James Watt and the early steam labs turned a kettle into the Industrial Revolution and hundreds of boiler explosions. You wake up in a cluttered 18th century workshop that sounds like it's about to detonate. Brass pipes rattle, valves hiss, and in the corner, a kettle the size of a horse wheezes like it has asthma. Standing proudly beside it is James Watt, Scottish engineer, caffeine addict, and the man who turned tea time into thermonuclear progress. It's the 1760s, and Britain runs on coal, muscle, and mild delusion. The Newcomen steam engine, the best they've got, wastes about 3/4 of its heat-boiling water. It's already boiled. Watt, then a mathematical instrument maker at the University of Glasgow, is asked to repair a model of the thing. Instead, he improves it so much he accidentally restarts civilization. While taking a Sunday walk in 1765, he realizes that the real problem isn't the steam, it's the cooling. He invents the separate condenser, a second chamber where steam can turn back into water without killing pressure in the main cylinder. That single tweak multiplies engine efficiency by a factor of 3. His notebook that day contains one of the least dramatic sentences in engineering history. The idea came into my mind. Translation: I just reinvented power. By the 1770s, Watt's partnership with Matthew Boulton in Birmingham turns this design into hardware. Their foundry, the Soho Manufactory, becomes a factory that builds factories. Watt's engines pump mines dry, spin textile mills, and drive the first industrial machines the world has ever seen. Humanity, for the first time, divorces work from muscle. The Industrial Revolution begins with a man staring at a kettle and thinking, what if this exploded productively? Of course, progress comes with side effects. Early boilers had the structural integrity of a bread tin. Engineers were improvising with pressure, metallurgy, and hubris. The 19th century becomes an age of boiler explosions, and every newspaper in Britain dutifully records them. One witness in 1815 described a cotton mill engine blowing through the roof and into eternity. Each catastrophe teaches someone a new word for safety valve. Watt himself spends years warning others against high-pressure designs. Ironically, those designs, once perfected, make steam travel possible, powering trains, ships, and eventually global empire. Watt measures success in horsepower, literally comparing his engines to horses because investors need familiar numbers. It's marketing genius. You're not buying an engine, you're buying the labor of 500 imaginary horses that don't need feeding. The term still survives in car ads, proof that branding can outlast the physics it describes. By the time he dies in 1819, Watt has transformed the world's metabolism. Energy becomes mechanical, factories hum, and humanity steps onto a conveyor belt it can never really step off. The age of steam means productivity, pollution, and profit, an unstoppable trilogy. You glance at the roaring contraption before you, half amazed, half terrified. Watt wipes soot from his face and says, "Power is my mistress." The machine hisses in agreement. A rivet pops from the boiler and embeds itself in the wall. You take a careful step back. Civilization, it turns out, runs on very loud kettles. Block 3. The industrial inventors, progress at gunpowder speed. The 19th century was one long boom, sometimes literal. Industry conquered nature, steam conquered distance, and a few inventors accidentally conquered the ozone layer. Alfred Nobel, 1867, created dynamite to help miners, armed every empire instead. You wake up in a 19th century laboratory that looks like a bakery run by arsonists. Glass tubes, wooden crates, and jars labeled nitroglycerin, handle carefully, sit on every shelf. At the center stands Alfred Nobel, Swedish chemist, poet, and man who accidentally gave the world its loudest moral dilemma. It's 1867, and the world is exploding, sometimes literally. Miners and engineers need a safe way to blast rock, but the best option available, nitroglycerin, is so unstable that sneezing near it counts as a workplace hazard. Nobel has already lost a lab, and his younger brother Emile to one of those controlled experiments. Most people would quit chemistry at that point. Nobel doubles down. He notices that nitroglycerin becomes less volatile when absorbed by a soft, chalky clay called kieselguhr. The result is a putty-like substance that can be shaped, stored, and detonated only when triggered by a blasting cap. He names it dynamite, from the Greek dynamis, meaning power. He patents it, demonstrates it calmly to reporters, and changes human industry overnight. Miners cheer, railroads expand, mountains get holes punched through them. Nobel thinks he's solved a humanitarian problem. Less labor, fewer accidents. Within a few years, every army on Earth is buying it. Dynamite bridges the gap between mining and militarization faster than any government regulation can blink. By the 1880s, Nobel's fortune is built on controlled destruction. He feels uneasy about it. In 1888, a French newspaper mistakenly publishes his obituary under the headline, "The Merchant of Death is Dead." The article claims he became rich by finding ways to kill more people faster than ever before. Nobel reads it over breakfast and realizes he has time to change the ending. He spends his remaining years trying to balance the equation. He funds pacifist movements, writes bleak love poetry, and drafts a will, leaving the bulk of his estate to a series of annual awards honoring progress in science, literature, and peace. When he dies in 1896, Europe is still arming itself with his invention, but his name soon becomes synonymous with human achievement instead of demolition. Today, the Nobel Prizes are handed out under chandeliers instead of in blast craters. Dynamite still builds tunnels and tears apart hillsides, but its creator's conscience survives in gold medallions and polite applause. You watch Nobel tamp a stick of dynamite into a hole, light the fuse, and calmly step back as the earth shudders. For construction, he says, the shock wave rolls over you, dust and revelation in equal measure. Progress, it turns out, has excellent aim, but terrible collateral. If you're still watching and haven't accidentally burned down your workshop, click subscribe so you don't miss the next episode of Historical Geniuses Detonating Civilization for Fun. It costs nothing, unlike Alfred Nobel's therapy bills. Nikola Tesla, 1890s, shot electricity through New York for fun, accidentally electrocuted his entire fortune. You wake up in a Manhattan laboratory that hums like a thunderstorm in a bottle. The air crackles, ozone stings your nose, and in the middle of the chaos stands Nikola Tesla, 6'2", immaculate mustache, and eyes that look like they haven't blinked since the Austro-Hungarian Empire. He's holding a metal rod longer than a sword, surrounded by arcs of blue lightning. Welcome to the 1890s, when one man decided to personally introduce New York to God's favorite party trick. Tesla was born in 1856 in what's now Croatia, the son of a priest and a mother who built mechanical gadgets for fun. He memorized entire books as a child and claimed to see flashes of light with every thought. By his 30s, he had already revolutionized electricity with alternating current, AC, a system far more efficient than Thomas Edison's direct current, DC. The war of the currents begins. Edison shocks animals in public demonstrations to prove AC is dangerous. Tesla, naturally, decides to prove it's safe by running it through himself. He sets up demonstrations where he channels thousands of volts across his body, illuminating lamps from his fingertips like a wizard doing performance art. Crowds gasp. Newspapers call him the electric magician. He's not trying to entertain. He's trying to show that the world can be powered wirelessly, safely, and everywhere. The irony is that his showmanship becomes his undoing. Investors want fireworks, not philosophy. By the 1890s, Tesla is obsessed with his greatest idea, transmitting electricity through the air. At his Colorado Springs lab, he builds a coil taller than a house. Locals claim to see lightning bolts over 10 meters long shooting into the night sky. He describes it casually. My instruments were thrown out of adjustment by lightning discharges. Translation: he created artificial lightning and fried the town's power grid. Again. Then comes Wardenclyffe Tower, a massive transmitter he builds on Long Island to beam wireless power across the Atlantic. Backer J.P. Morgan funds the project until he realizes Tesla also plans to make energy free for everyone. Morgan asks, "Where do we put the meter?" Tesla doesn't have an answer. Funding disappears. The tower stands unfinished, humming faintly with unfulfilled genius until it's demolished for scrap. By the early 1900s, Tesla's finances are gone. His lab burns down. He moves from hotel to hotel, feeding pigeons and writing letters about death rays and interplanetary communication. Some of those ideas later prove visionary, others less so. The man who electrified the world dies in 1943, alone in room 3227 of the New Yorker hotel, surrounded by blueprints and unpaid bills. Yet his fingerprints are everywhere: radio, remote control, fluorescent light, modern power grids. Humanity still runs on his equations, if not his optimism. You glance around his flickering lab. Tesla grins, throws a switch, and the room erupts in lightning. "We are conduits," he says, voice calm over the thunder. You take a step back as the sparks dance overhead. In that moment, you realize he was right. Genius can illuminate the world, or burn straight through it. Thomas Migley Jr., 1921–1944, invented leaded gasoline and CFCs, probably the single man who did the most damage to Earth's atmosphere. You wake up in a spotless 1920s laboratory in Dayton, Ohio, and everything smells faintly sweet, like chemical victory and impending doom. Glass beakers line the benches, each labeled with confident handwriting. Tetraethyl lead. In the center stands Thomas Migley Jr., engineer, inventor, and future environmental supervillain, adjusting his tie as if science were a board meeting. In 1921, working for General Motors, Migley tries to solve a nagging problem. Early car engines knock and sputter because of premature combustion. He experiments with additives, iodine, aniline, even melted butter, before discovering that a tiny dash of tetraethyl lead smooths everything out. Gasoline runs quietly. The engine purrs. Civilization applauds. Problem solved. Except lead is poison. Ancient Romans already knew this, but Migley insists it's harmless in minute quantities. To prove it, he performs one of the worst PR stunts in history. At a 1924 press conference, he washes his hands in leaded gasoline and inhales the fumes for 60 seconds. "I could do this every day without harm," he declares, right before taking a long vacation to recover from lead poisoning. Meanwhile, the factory producing tetraethyl lead, called the Standard Oil ethyl plant, becomes a horror show. Workers suffer hallucinations, convulsions, and die from acute exposure. Locals nickname it the House of Butterflies because victims reportedly saw insects before collapsing. The company blames overwork. Production continues. For decades, leaded gasoline fills the air of every major city, silently damaging brains, hearts, and ecosystems. But Migley isn't finished. A decade later, working for Frigidaire, he tackles another industrial nuisance: toxic and explosive refrigerator gases. In 1930, he develops chlorofluorocarbons, CFCs, stable, non-flammable compounds perfect for cooling and aerosols. He names one Freon, proudly demonstrating it by inhaling and exhaling the gas to blow out a candle. It looks safe. It feels safe. It will later help create the ozone hole. By the time scientists connect the dots, lead's neurotoxicity, CFC's atmospheric destruction, Migley is long gone. He contracts polio in 1940, loses mobility, and designs an elaborate system of pulleys to help him move in bed. In 1944, the contraption accidentally strangles him. A tragic, grimly poetic end. The man who mechanized convenience is killed by his own machine. Today, historians describe Migley as the most destructive single organism to ever affect the Earth. It's not malice, just catastrophic success. He solved every problem the wrong way, perfectly. You glance around the quiet lab as the air grows heavy. Migley smiles, holding up a glass vial. "It's progress," he says. Behind him, the world's engines begin to purr. Soft, smooth, and utterly toxic. Block 4. The Military Masters. Brilliance meets boom. War has always been the world's fastest R&D department. These geniuses built machines so advanced they couldn't tell progress from apocalypse until it was too late. Archimedes, 212 BC, built war machines so effective they prolonged a siege, and got himself speared for drawing in the sand. It's 212 BC, and the Second Punic War is ending badly for Carthage's allies. Rome has besieged Syracuse for 2 years. They expect a quick victory. After all, this is a city of scholars, not soldiers. But Syracuse has Archimedes, and Archimedes has ideas. He designs ballistae and catapults that fire at multiple ranges, cranes that lift enemy ships out of the water, and possibly, depending on which ancient historian you believe, a giant mirror array that sets sails ablaze by focusing sunlight. The Roman fleet learns an important lesson. Never underestimate a man with math and free time. Plutarch writes that Roman ships were crushed or flipped by enormous hooks and beams operated from the city walls. Soldiers describe boulders dropping from nowhere, smashing siege towers with terrifying precision. Each new weapon seems perfectly calculated to mock Roman engineering. One officer reportedly said, "Archimedes uses our own strength against us." That's accurate. He literally designed compound levers that multiplied human force. The siege drags on. Eventually, treachery opens the gates, and Roman troops flood the city. They have strict orders: capture Archimedes alive. He's too valuable to kill. But genius and chaos don't mix well. As soldiers ransack houses, they find an old man on the floor, tracing a geometric problem in the sand. A Roman officer shouts at him to stand. Archimedes, absorbed, mutters, "Do not disturb my circles." The soldier spears him on the spot. It's one of history's purest ironies. The man who invented pulleys calculated pi, and armed a city with physics dies because he's too focused on a math problem to look up. His body is buried under a tomb marked with a sphere and a cylinder, the shapes he proved related by exact ratio. Centuries later, Cicero finds it overgrown with weeds. Humanity keeps rediscovering his genius every time it needs to build or destroy something efficiently. You stand among the ruins of Syracuse, the harbor still smoking, and look down at the circles he left in the sand. Simple lines, infinite consequences. From siege engines to calculus, Archimedes proved that knowledge can move the world. Unfortunately, sometimes it also crushes what's standing too close. Fritz Haber, 1915, gave us fertilizer and chemical warfare, won a Nobel Prize and eternal controversy. You wake up in Berlin, 1915. The air smells of coal, ambition, and ammonia. A man in a military uniform stands in a laboratory full of gas cylinders, scribbling equations on a blackboard. That's Fritz Haber, chemist, patriot, and proof that brilliance doesn't always equal wisdom. A decade earlier, Haber had done something extraordinary. In 1909, with engineer Carl Bosch, he perfected the Haber-Bosch process, a method of turning nitrogen from the air into ammonia. The invention changed everything. It provided the foundation for modern fertilizers, feeding billions who would otherwise starve. Albert Einstein once called Haber's discovery the turning point in human destiny. If the story ended there, we'd remember him as one of humanity's greatest benefactors. But history had other plans. When World War I erupted in 1914, Germany was starving for both food and explosives, and both required nitrogen. Haber's process kept the war machine alive, but he wanted to contribute something more direct. As a proud nationalist, he offered science itself as a weapon. He personally oversaw the first large-scale use of poison gas at Ypres in April 1915. Imagine the scene. 6,000 canisters of chlorine gas released at once, a pale green cloud rolling across no man's land. Allied troops, unprepared, choke and flee as lungs dissolve. It's the birth of chemical warfare. Haber is promoted to captain that night and celebrated as a hero in Berlin. His wife, Clara Immerwahr, a chemist herself, calls it a betrayal of science. Days later, she takes his service pistol and ends her life in their garden. Haber leaves the next morning for the Eastern Front, leading more gas attacks. The war ends, the world recoils, Germany loses. Haber becomes an exile, then a pariah. Yet the paradox of his work deepens. His process continues to feed the planet. By mid-century, half the nitrogen in every human body on Earth comes from his invention. The same reaction that nourishes wheat also built bombs. In 1919, he's awarded the Nobel Prize in Chemistry for synthesizing ammonia, an honor many refuse to applaud. Einstein, once his friend, drifts away. The League of Nations bans chemical weapons, but every major army keeps researching them, inspired by Haber's efficiency. The legacy is split clean down the middle: bread and gas, life and death, fertilizer and massacre. By 1933, Jewish by birth but patriotic to a fault, Haber flees Nazi Germany. He dies a year later in a Swiss hotel, heart failing, body worn out, mind haunted. Within a decade, the Nazis weaponize one of his earlier insecticides, Zyklon B, for genocide. You stand in his silent lab, surrounded by flasks and contradictions. The air smells faintly of chlorine. Haber believed science could elevate nations. It did, just not the way he hoped. The V2 engineers, 1944. Rocket science that killed thousands before putting men on the moon. You wake up in a freezing underground tunnel near Peenemünde, Germany, in 1944. The walls tremble with the echo of engines, and the air smells of fuel, oil, and fear. Engineers huddle over blueprints by lantern light, calculating trajectories that reach beyond the atmosphere, and directly into London. This is the birthplace of the V2 rocket, the world's first long-range ballistic missile. It's also where the modern space age begins, in a factory built on suffering. At the center of it all stands Wernher von Braun, a 32-year-old aerospace prodigy who dreams of space travel but works for the Third Reich. To him, rockets are the future, sleek, mathematical, inevitable. To Hitler, their vengeance. The name V2 stands for Vergeltungswaffe 2, Vengeance Weapon 2. Its purpose is simple: terror. The first V2 launches in September 1944, arching 80 kilometers into the sky before descending at supersonic speed onto London. No warning, no sirens, just impact. Each one carries a 1-ton warhead. Each one is a masterpiece of engineering and a war crime in motion. Von Braun's team achieves miracles of physics. The V2's liquid fuel engine burns ethanol and oxygen, reaching speeds over 5,000 kilometers per hour. Faster than sound, faster than any human-made object in history. The problem is not the math, it's the ethics. The rockets are built in the Mittelwerk, an underground facility staffed by concentration camp prisoners from Dora Mittelbau. Over 20,000 die from starvation, disease, or execution, more than were killed by the rockets themselves. After Germany's collapse, the Allies race to capture both the technology and the engineers. The Americans win. Under Operation Paperclip, von Braun and his team are quietly relocated to the United States. Their Nazi records are scrubbed. Their new employer, NASA. Within 2 decades, the same minds that once aimed rockets at cities are launching them at the moon. On July 20th, 1969, as Apollo 11 lands on the lunar surface, von Braun watches from mission control. Reporters call him a visionary. Few mention the factory tunnels or the prisoners who died in darkness to make that vision possible. The V2 remains one of history's most perfect contradictions, a weapon of terror that became a vehicle of wonder. It embodies the question that haunts every age of invention. Can knowledge ever be innocent once it's been weaponized? You step into the cold tunnel, staring at a half-assembled rocket gleaming under torchlight. A guard shouts, an engine whines, and somewhere far above, the sky waits to be conquered. The cost of reaching it is already written into the walls. Block 5. The thinkers who overthought everything. They didn't build engines or weapons, they built ideas. And then those ideas built everything else, including some very awkward contradictions. René Descartes, 1649, philosophized himself into pneumonia after convincing the Queen of Sweden to do 5 a.m. logic sessions. You wake up in Stockholm, January 1649, and immediately regret it. It's pitch dark, -15 degrees, and your breath freezes mid-air like a visible mistake. Across the icy palace courtyard walks René Descartes, the French philosopher who invented both modern rationalism and the world's worst morning routine. By now, Descartes is 60 and famous. He's written Discourse on Method, introduced analytical geometry, and declared, Cogito ergo sum, I think, therefore I am. He's Europe's intellectual celebrity. So when Queen Christina of Sweden, a 22-year-old scholar obsessed with philosophy, invites him to tutor her, he accepts. He imagines civilized debates over wine. He gets frostbite and insomnia instead. The Queen insists on meeting at 5 in the morning in her unheated library, because that's when she feels most clear-minded. Descartes, who usually sleeps until noon, tries to oblige. Every dawn he stumbles through the snow, muttering that reason should never require hypothermia. Sweden in winter offers 3 hours of daylight and 0 mercy. He lectures on logic, mind-body dualism, and the proof of God's existence, while shivering in 17 layers of wool. Within weeks, his body rebels. He catches pneumonia, the one phenomenon he can't rationalize away. According to witnesses, he stays polite even as his lungs collapse. The body, he once wrote, is but a machine. Unfortunately, his own machine has frozen solid. On February 11th, 1650, Descartes dies in his patron's palace, far from the mild sun of France. The Queen feels vaguely guilty, but continues hosting philosophy breakfasts. His body is buried, exhumed, moved 6 times, and eventually loses its skull, which now sits in the Musée de l'Homme in Paris, covered in doodles by admirers who couldn't resist literally writing on his mind. Descartes' method, doubt everything, rebuild knowledge from reason, becomes the cornerstone of modern science. Ironically, his death proves that even the most rational mind can't negotiate with pneumonia. You watch him shuffle toward the library one last time, candle flickering in the Arctic gloom. It is not enough to possess a good mind, he says softly. It must be applied. Then he coughs, clutches his chest, and mutters something that sounds suspiciously like, "Next time, I'm teaching by correspondence." Jean-Jacques Rousseau, 1762, preached child-rearing perfection, abandoned his own 5 babies. You wake up in Paris, 1762, surrounded by candlelight, pamphlets, and the unmistakable smell of self-righteousness. At a cluttered desk sits Jean-Jacques Rousseau, philosopher, writer, and the 18th century's patron saint of "do as I say, not as I do." He's scribbling furiously, shaping ideas that will ignite revolutions and parenting debates for centuries, while conveniently ignoring the screaming hypocrisy echoing just outside his study door. Rousseau's new book, Émile, or On Education, claims to reveal the secret to raising perfect children. He insists that early childhood should be guided by nature, freedom, and moral purity. Man is born free, he writes, and everywhere he is in chains. It's poetic, inspiring, and deeply awkward once you realize he's already chained up 5 of his own newborns by sending them to a foundling hospital before they could even walk. Between 1746 and 1752, Rousseau fathers 5 children with his longtime partner, Thérèse Levasseur, a laundress. Each time, he claims poverty and unfitness for fatherhood as justification for dropping them off at the Hôpital des Enfants Trouvés, a public orphanage with a survival rate barely better than 0. The same man who writes entire treatises about nurturing young minds doesn't know or care what became of his own. Historians estimate that almost none of those children survived to adulthood. When confronted years later, Rousseau defends himself in one of history's most spectacular displays of moral gymnastics. He insists that his children were better off without him, since orphanages would give them a proper education. In other words, state-sponsored parenting is fine, as long as it's not mine. Voltaire, his intellectual rival, famously mocked him, writing, "No one has ever written more eloquently on the duties of fathers while being less of one." Despite his personal train wreck, Rousseau's ideas revolutionize political thought. His social contract inspires both democratic constitutions and the French Revolution. Émile shapes modern theories of childhood development. In the grand irony of history, the man who couldn't parent his own kids ends up shaping how the world parents theirs. In 1778, he dies in rural France, convinced the world has misunderstood him. He's right, but not in the way he hoped. His tomb in the Pantheon reads, "He gave new life to his century." You glance at it and can't help thinking, he didn't manage that for his children. You watch Rousseau seal another envelope, pausing to admire his own prose. He sighs, "To write about virtue is to make it live." You resist the urge to point toward the nearest orphanage and say, "Apparently not." Karl Marx, 1848, wrote about equality while living off Engels' money and never doing dishes. You wake up in a cramped flat on Dean Street, London, 1850. The air is a mix of ink, smoke, and unwashed genius. Papers are everywhere, half-finished manuscripts, unpaid bills, and the unmistakable sound of someone passionately explaining economics to a person who didn't ask. That's Karl Marx, philosopher, revolutionary, and history's most famous houseguest. Marx is broke, brilliant, and absolutely certain the world is one good uprising away from paradise. He's writing the Communist Manifesto, 1848, and later Das Kapital, hammering away at ideas that will reshape politics for centuries: class struggle, labor value, historical materialism. His beard is magnificent, his hygiene less so. His wife, Jenny von Westphalen, a baron's daughter turned revolutionary partner, is pawning furniture to buy food while Marx lectures about the evils of property ownership. The irony is legendary. While preaching equality and collective ownership, Marx survives almost entirely on the financial support of his best friend and co-author, Friedrich Engels, heir to a wealthy textile fortune. Engels works in his family's Manchester factory, exactly the kind of capitalist enterprise Marx condemns, and mails money to keep the Marx family alive. It's socialism with a direct deposit. The household is chaos. Marx spends his days writing in the British Museum reading room, his nights coughing up industrial soot and conspiracy theories. His children run barefoot through the neighborhood, and neighbors complain about the smell of perpetual tobacco smoke. One child dies of malnutrition, another of illness. Marx blames capitalism, but the unpaid rent probably didn't help. Still, the ideas take hold. The Communist Manifesto opens with the line, "A spectre is haunting Europe, the spectre of communism." What he doesn't mention is that the spectre is also haunting his landlord. He preaches that private property corrupts mankind, but when asked to share writing credit equally with Engels, he politely declines. The man who dreamed of abolishing hierarchy can't quite stop acting like management. By the time of his death in 1883, Marx has achieved exactly 0 of the revolutions he predicted. He's buried in Highgate Cemetery, beneath a massive bronze bust that looks suspiciously expensive. The inscription reads, "Workers of all lands, unite." Somewhere, Engels footed the bill. You watch Marx wave his pipe, eyes blazing. Philosophers have only interpreted the world, he declares. The point, however, is to change it. Jenny rolls her eyes and gestures to the dishes piled in the sink. You realize he might have started the wrong revolution. And that's the story of humanity's brightest accidents. Every time a genius fixes one problem, 3 new ones crawl out of the lab. So the next time you forget your keys, remember, you're still doing better than the guy who invented leaded gasoline. This is ancient absurdity. Thanks for watching. Try not to invent anything dangerous before the next episode.